today's lesson is going to concern the cost of money for construction. Basically, in the construction industry, we purchase very large pieces of equipment, and we have to determine how much money we're going to put away each year to assist in developing that. So it's very important that we understand the cost of money. And in this particular case, the cost of capital is the future value minus the present value. Since it takes years to accumulate funds to pay for major equipment, we're always comparing money in terms of future value minus present value. And this formula is the basic representation of how we are always going to look at doing this in a manual method. Now, most accountants have prepared these tables for the layman, which is what I refer to construction professionals, since our core business is not about determining financial calculations. They've determined this formula to make it easy for us to understand what we're trying to do in terms of making basic computations. So again, F stands for future value, P stands for present value, I stands for the interest percentage, and N equals the number of periods. Now those periods can be either in the terms of months or years. It's very important to look at the statement problem to determine exactly what the unit is. So on the screen you see the definition. F equals future value, P equals present value, I is the annual compounding interest rate, and N represents the total number of periods. Now when you look at this, you see the green arrow going from the beginning to the end. These are called compounding calculations, where you have the present value of funds and you're looking what the future value is. When you start in the future with the future value and you're trying to go back to the present value, that's called discounting. What you see on the screen here are the tables that these accountants have put together to illustrate, make it easy for performing these functions. The 15% represents the percentage interest rate that you would be charged for whatever period you select. The highlighted N represents the number of periods. And again, that can either be months or years. So what you're going to do is, the next important thing is to determine what are you really looking for from your problem statement. You always want to dial it down to, in terms of, I'm finding F given P, or I'm finding P given F. Again, we're talking about what you're looking for. So when you say I'm finding F given P, that means the variable that you've been given is the present value and you're looking for the future value. Now as you see here, the box that I'm describing is a single payment where you're either looking for present value or future value. The next box over, where it says uniform payment series, has to deal with, similar to an annuity, like when you retire and you want to know at the end how much money you have left to retire on. So A stands for annuity, F still stands for future value, P still stands for present value. Okay, so now that you understand these interest tables, understand that there will be interest tables for every interest rate. And those are easily found on the internet, or again, we'll provide those for you in class or whenever you have a quiz. So let's go forward now and let's talk about how you actually do the computations for each one of these problem statements. In front of you, you see an Excel spreadsheet, and I've blanked out the values so I can take you through a step-by-step process on how to do the values. The problem statement at the top. A crane which cost $1.5 million today needs to be purchased in 7 years. How much do I need to set aside each month if I'm getting a 5% interest rate on my initial funds? So again, you want to take the problem statement and you want to determine what are your variables. That's the most important thing that you can do. Okay? We're going to take a look at this, and I'm going to start filling in what variables we have. So our present value is $1.5 million. You can see where I put in the amount next to the P. We have $1.5 million in today's money to invest. Over, you see the other variables, the interest, future value, and the number of months. Now, this particular problem is not an annuity problem, so I'm going to get rid of that particular cell. Okay? So now let's keep moving on. So the next thing that we're going to look for then is what is the other element within the problem statement. Well, we have 7 years. So N is equal to 7. Now again, remember, it's very important that whenever you finalize a problem, that you put it in terms of the right period that you're being requested. But right now, all we need is 7. Our interest rate's been given to us at 5%. So the variable that we're looking for is the future value of what this particular piece of equipment is going to cost us in 7 years. And today's present value, we know it's $1.5 million. So we have been able to determine that our formula is going to be find F given P. So over to the right, I have a small breakout of the table that we've been given. Okay? So we're going to come over to here, and we know that we're looking for F given P. It's 5%, and we're going to scroll down to where we find the value N, and in this particular problem, it's 7. So the multiplier factor that we have, which I'm about to highlight, okay, is 1.407. That's our multiplier factor from our table. So we're going to come over here, and we're going to highlight 1.407. Now, in order to find the future value, we're going to take 1.407 and multiply it times 1,500,000. You can see on the screen what the formula setup is. Okay? So let's do the math. $1.5 million times 1.407, and that's going to give us a value of $2,110,000. That is what the crane will cost in terms of future value after 7 years. So I've now filled in all the variables on the left-hand side just so we get a better feel for it. So now we're going to take the $2,110,000, and we have to find out what it is in terms of monthly amounts that we have to put in. Well, I'm going to figure 7 just because it's breaking it down to the component that we did it. So we're going to take $2,110,000, divide it by 7 years, and that would mean that we'd have to put in approximately $301,000 per year. So if I take and further divide that number by 12, I'm going to come up with the monthly payment that has to be added to the $1.5 million at a 5% interest rate to accrue to our future value of money so that we have enough money to pay for the crane. And you can see it's a little over $3,500. That's as simple as it gets on how to calculate these when you don't have a financial calculator or you don't have an internet tool to do the calculations for you. So one of my favorite sites is called the Money Chimp, and I use this to be able to confirm that I indeed have done the math correctly. So what you see below is we've input $1.5 million at 7 years to grow at a 5% interest rate, and it comes up with $2.110 million that we'll have at the end of 7 years. That's pretty close to the number that we manually calculated. And as they say, that's close enough for us to know as construction professionals how much we need in order to purchase this crane. So I hope you've enjoyed your lesson today, and I hope this clarifies for you how to calculate the future value of money given the present value.